So following on from the previous two videos, we were trying to sum up this alternating series. So in order to do that, we would consider this function. This function can be viewed as this series, provided absolute value of x is strictly less than 1. So we then broke this up. Into one block plus another block. So this block here can be broken up into one block plus another block. Well, this one here stays the same. But then as it turns out, this block here turns out to be this thing here as n heads towards infinity. So we've seen this in the previous two videos. So now from here, integrate both sides. So we know that this function here can be represented by this, provided x is strictly less than 1. So now integrate this side. So when you integrate this, it gives you natural log of 1 plus x, and then integrate this. That will then give you this evaluated from 0 to 1, and then integrate this. We don't know how to integrate this yet, so let's just leave it as this form. This one's quite easy to integrate. We can do it straight away. Easy to integrate. We can do it straight away. This one here is slightly more complicated. So let's just leave it in this form. We will sort this out later. Okay. So now remember up here, this can be represented by this, provided provided the absolute value of x is strictly less than 1. But then you might put up an argument and say, how can you evaluate it from 0 to 1 when you know that when x is 1, it breaks down? So when x is 1, when x is equal to 1, it breaks down. You see, in order to turn this into a series, x must always be between -1 and 1. But when you evaluate it from 0 to 1, you are doing it dead on 1. So you might put up an argument saying that how is that even possible? Well, remember when we were doing this, let's say you've got a graph of 1 over square root of x. Back in our section on improper integrals, we can integrate it from b to 1. So and then later on we can allow b to head towards 0. Remember when we were doing this, we would integrate it from b to 1, and then later take the limit as b heads towards 0. So this b here heads towards 0, and it gave us a legitimate answer. So even though this thing breaks down when it's 1, even though it's not valid when it's 1, we can integrate it to b, and then later allow b to head towards 1. So we're going to use that same technique. Okay, so from here you might put up an argument saying that it breaks down dead on 1. How can you integrate it from 1? So let's just integrate it to b, and then later on we can allow b to head. We can take the limit as b heads towards 1. Okay, so let's just do it from 0 to b, from 0 to b, from 0 to b, from 0 to b, because we're still unsure. Then on 1 we're still vague. We're still unsure. So let's just do it to b. So we are currently here. So hang on. So now if you put this into here, so that will be natural log of 1 plus b, and then put this into here, so that will be natural log, take away natural log 1 plus 0. Now natural log of 1 is 0, so this thing here disappears, so all that you're left with is this. Now take the limit as b heads towards 1. So that's really the same as you doing natural log of 2. So that's really you doing the natural log of 2. So looking at this here, if you go back to here, it's exactly the same thing here. So you can just put 1 into here, so that's natural log of 2, take away natural log of 1, which is 0. But the point is that you can put it in here. So even though you're unsure about it being dead on 1, you can do it to b, and then take the limits as b heads towards 1. So looking at this here, if you put this into here, that will then give you this thing here, and then if you put 0 into here, then then everything will be 0, because so if you put it into here, it will be 0. The point is that this whole block here will then become this, and then take the limit as b heads towards 1. Well, b heading towards 1, that's nothing really breaks down here. So going back to here, you can just simply put 1 into here. When you put 0 into here, everything will be 0. But even though you're vague, even though you feel uncomfortable dead on 1, you can do it to b, and then put b into here, and then take the limits as b heads towards 1. Then it will be in effect be the same as you putting the 1 into here. So when you put this into here, that will then give you this whole thing here. Now we are unsure about this, so we're going to sort this out in the next video. So leave this as it is. Leave this as it is. We're going to sort this out in the next video. But yeah, I will continue in the next video.